Okay, this is a bearing pocket test. I'm just got a scrap piece here, and I'm trying to mill out a bearing pocket for the Z mounts, the Z-axis mounts, and this is 26 millimeter bearing, and man, that's perfect tight fit. Just slides in there. I'm going to go on down to the max depth, which is about 8 millimeters, and then I'll do the Z mount. By doing it this way, it helps you learn the Mach 3 software. It lets you learn the different feed rates for the different materials that you're cutting, and the depth of cut, so this is a good learning curve. So I would highly suggest anyone converting one of these, convert your X and Y first, and then use those axes to make your mounts for your Z axis. Well, I finally figured out the tool change, and so now I don't have a big scratch over the, when it crosses over from the from the Z to the arrow, as you can see. Okay, so working on the Z-axis. As you can see, I have the mount up here, and I have my ball screw installed. I still got to put a double nut, and of course the stepper motor on there. But wanted to show how the ball screw is attached. I just attached it with these two holes. Now, had I took the housing apart before I actually started the modification, I may have made a couple of changes. This is a ball nut, and as you can see how it's designed, what I did was I ground it right here to get relief for back here. Don't know if you can tell, but as you can see, I ground it that way. Now, if you turn it this way and install it, you have 3 screws that you can mount right here, and probably would be a little bit better. There's no clearance issues with the belt drive, so I think if I were going to do it again, I'd probably turn the ball nut in this orientation. You would still have to grind off all that, but that shouldn't be a problem. So that's that. Another thing I realized, and of course I kind of anticipated, the top of the column itself is not square. So once I mounted my bracket up top, I realized that my ball screw was kind of crooked and not in the center, which was causing clearance problems inside the housing. So I had to shim it underneath. I just shimmed it a little bit. As you can see, there's a little metal shim right there, aluminum shim. And now the column is perfectly centered in the slot, and turned out real good. It moves smoothly up and down, and now I'm afraid shavings and stuff might get in here, so I'm probably going to put some kind of maybe some aluminum duct tape right here before I bolt the spindle back on, because you really don't want to get any kind of debris inside your spindle housing. I'll probably remove the intermediate shaft and I'm not going to use that anymore with the belt drive conversion, so I'll probably just go ahead and remove that, and then, like I said, put some kind of cover right here. I like this design. I think it works well. I didn't have to remove too much metal inside there. I just used a grinder with a disc, and this casting is real soft, and it really just ground away real easy. Probably took about 15 minutes to do that or less. Had to do here, and also right in here. But it wasn't a big deal. So that's that. I'm going to go ahead and assemble it and see if I can get the Z motor mounted and see if we can get some movement going. Okay, this is the Z-axis. I finally got it all hooked up and working. And with the ball nut being on top, of course you lose about this much travel. But I don't think, in my personal use, I don't think that losing that much travel is actually going to matter that much, so I'm okay with that. I decided, I could take it and stick it inside the housing, but the way the housing's made, I would have had to make some kind of bracketry, and this was just the simplest. I just had to tap 2 holes, and it works flawlessly like it is, so I'm okay with it. As you can see, it moves good. The motor just clears. I have about 1/8 of an inch there, so that works real well. And as you can see, it works good. And right there, I've probably lost about 1.5 inches travel. But if you look in the scheme of things, you really didn't lose that much because you got about 10 inches of travel. So from the spindle down to the base of the vise, I have about 8.5 inches. A little more than 8.5, about 8 5/8 inches, and down to the table there's a good 9 3/4 inch to the table. So I don't think that I'll be milling anything that tall. So that is the Z-axis. It's all hooked up. It works good. Rapids just fine. No binding. And I still have the spring tension on here, and I'm at the end of the travel at this moment with the torsion spring system. And you get about 6 3/4 inch of travel on the Z, 6.75. That's probably going to be good for right now. Anytime you use the vise, you're not going to really need to go down that much. But I intend to do an air spring conversion. I'll probably attach the air spring somewhere here, maybe in the same position as this, and then attach it down at the bottom somewhere, and try to get the full amount of downward negative travel on the Z-axis. But for right now, I'm really happy with the way that it turned out. So I hope hope this has helped, and this just gives you a different way to do your Z without having something hanging over the side and down and trying to put it in a bind. I think having it right in the center really works well. So, and it really, to be honest, it wasn't that difficult. This mount, although there's more pieces in this mount than the other two, the X and the Y mounts, to mount it, really just a couple of holes, and take a grinder and just hollow out and mill that out a little bit. So, and I think overall it turned out really well. All the axes are, as you can see, all the axes move very smoothly, and those work really well. The X and the Y, of course, you've already seen from other videos, work really well, and they wrap it pretty well. Overall, the whole conversion turned out really nice. So I've already made some parts with the Z mounts. I did this. I saw that on the CNC Fusion kit. It's really cool. So, and I decided, well, that would be my first cuts, would be that, to see if how that would turn out. Turned out really well. So I just used the center drill as an engraving tool, and the cuts came out fairly smooth with just the engraving tool. So thanks for watching the videos, and if you got any questions, feel free to leave a message. Thanks.